Ma'am, I have given you the right as a co-host.
Okay.
Yeah. Please share your screen. Ma'am, your screen is clear and
Yes.
your video is also clear and audio is also clear.
Good.
Yeah. So I welcome all the participants on the day 2 of this faculty development program sponsored by AICTE ATAL and organized by CSMSS Chhatrapati Shahu College of Engineering. The FDP is on leveraging the cutting edge technologies on sustainable agriculture practices. So today we have a day 2 is there and we have two speakers are there. On the first session, we have Dr. Vinaya Gokar ma'am is there. So the topic is leveraging AI for agriculture, data analysis, prediction, and forecasting. Let me introduce her. Dr. Vinaya Gokar is working as a professor in Department of EEE, MIT World Peace University, Pune. She has completed her PhD in 2009 from Amravati University in Electronics Engineering. With over 32 years of teaching experience, her areas of research include the Internet of Things, computer vision, edge intelligence, etc. 6 research scholars have received doctoral degree under her guidance. She has research grants worth rupees 50 lakhs from various funding agencies to her credit. From last 32 years, ma'am is working in the image processing, then machine learning and AI to the different agriculture practices. So I request ma'am to start with her presentation. Ma'am, please.
So thank you, Praveen. So I'm happy to see 97 participants in the meeting. Generally, it's evening time, the time where you all want to be with your friends or with family. You have attended or you have at least logged into the meeting. Hope I'll be able to come to your expectation. Okay, so as you can see, the topic is leveraging AI for agriculture, data analysis, prediction, as well as forecasting. We'll begin with the topic. So wherever you want, you can stop me in between. You can either ask your question if you are allowed to unmute yourself, or you can give a question in your chat window so that I will be able to answer it. We'll try to keep it as interactive as possible. So the first question which should come to your mind whenever any topic comes in front of you is why? Why we want to study a particular topic in this particular. So let's say here the answer is why we want to apply AI to agriculture. The basic reason behind it, if you say we want to make the agriculture sustainable. The reason behind this, the global population is projected to reach 9.7 billion by 2050. What does it mean? So this means that now we'll have to increase the food production. We have to produce more food using fewer resources. So when I say I want to produce more using fewer resources, definitely it is an optimization problem. So any optimization problem, in order to solve optimization problem, you need to use AI, or AI is the, so earlier we used to call it optimization, now we call it AI or deep learning or ML. Second is to minimize its environmental impact. Again, it is a minimization problem, or optimization problem. Definitely we need to use AI. Minimize the pesticide usage. Preserve and enhance natural resources such as soil and water. Definitely use of pesticides is deteriorating our soil, and which is not acceptable because same soil is to be used by generations to come. So we want to preserve the soil, we want to preserve the water quality, we want to enhance the natural resources. To encourage the practices like crop rotation, agroforestry, as we want to increase the food production, we want to find out the ways in which we will be able to do it. And in order to do that, definitely, we have to use the state-of-art technology, and today's state-of-art technology or every technology is to be supported by AI. So definitely, agriculture is also a region or a vertical wherein many applications of AI can be seen. So we'll try to see how does AI improve crop yield in the agriculture. Now we want to use it, there's no doubt in it, but how does AI will improve the crop yield in agriculture? How can we enable prices, or how can we allow the same crop to get higher price? Again, optimization problem. So what challenge do farmers face with AI implementation? We'll try to answer these questions. Maybe at the end, I would like to again talk about the projects which we are doing at MIT. But before that, we'll try to answer these few of the questions. So the basics with which we are going to start is, what is the data? When we say data analysis, prediction and forecasting is the topic assigned to me. So what is data? What is to be predicted and what is to be forecasted? Generally, prediction and forecasting, there is a small difference between the two. In case of forecasting, we need to use the time series data. For prediction, we can work even with the real-time data. So we'll try to understand the food value chain initially. So this food value chain, we can divide into different parts. When you say agriculture, this does not only mean farming. So when I want to say the data is related to agriculture, this does not mean that I have the data only from the farm. So farming is definitely one of the component of food value chain. But in addition to improve the rate at which we are producing the goods, or in order to improve the quality of the farm food, what is required is we need to take care of the complete food value chain. So at the input, you have OEMs, we have seed companies, chemical, fertilizer, financial instruments, institutions, government or legal institutions. We have the institutes forecasting the weather, giving us information regarding. All these are the components which are outside our farming, but they are allied to farming. Without using these, so when you say data of the agricultural, so this data definitely, not only farming, it is the data from the input supply. After farming, when you are harvesting your goods, you have post-harvest data. So post-harvest data may have processing, the transporters, the processors, the agents, distributors, and then finally the consumer. So when you want to improve the food production, you need to take care of the complete food value chain. It's not only that working on applying AI to farming is going to solve the problem. In addition to applying the AI or artificial intelligence, or we can say deep learning algorithms or prediction regression algorithms to farming, we need to consider the complete supply chain. Now, just try to understand what kind of data we may have here. So when we say data, the first and the foremost is definitely the weather data on which your yield is going to be dependent. So basic, you can initially say that what you want to improve is the base yield of the day. So if I am able to increase the yield, then I'll think of the quality of the yield. So, but the first thing which comes to my mind is to increase the yield of the farm. So to increase the yield, and most of our farmers, they are still dependent on the nature. They are still using the natural resources for producing or in their farms. So weather data, which is temperature, rainfall patterns, humidity levels, wind speed and direction, solar radiation. So these weather forecasts or historical trends becomes the first or the most important data when we say, I want to do something. I want to apply AI to the agricultural field. In addition to that, the second kind of data you can say is the soil data. So soil type and texture. So which particular soil type is going to give me more produce as compared to another soil type. The nutrients which we are providing to the crops in order to again improve the yield. So these nutrients, generally used nutrients or basic nutrients are the NPK, which we call as nitrogen, phosphorus, and potassium. So what are the contents of these nutrients in the soil data? What is the organic matter level? What are the pH values? The moisture contents? So electrical conductivity of the soil. So all these factors, they affect the quality of the produce. They affect the yield. So quality as well as quantity, both the things are dependent on the soil data as well. In addition to soil data, there's crop data where we know the growth stage and timelines. We need the yield potential. Again, important factor which is affecting your yield or is the pest or the disease susceptibility. So if the pest or diseases are affecting your farm, definitely your produce is going to reduce, your yield is going to reduce, your profit is going to reduce. So this is again an important data. The nutritional requirements, stress level, heat or drought or seed variety performance. So all these are the data which can become the base for your agricultural AI. Then again, you have the sensor data. Nowadays, we'll come to that point, but agriculture is becoming digital agriculture. I remember that before 10 years, when one of my students took the topic of IoT applications in agricultural field, I had to defend, or he had to defend a lot to prove to the committee that IoT is one of the topic related to electronics engineering or related to agriculture or can be integrated to agriculture. But now each and every one of you or each and everyone is ready to agree that IoT has become an integral part of many of the agricultural firms or agricultural. Many sensors are there in the farm and they are helping farmers to definitely increase the yield. So sensor data, many of the IoT devices which are there in the farm, they are helping us improve the performance. Then farm management data, whether to rotate the crop or use the same crop for years, planting and harvesting dates, equipment use or resources, operational cost. Again, many parameters which are going to final. We want to maximize the outcome. We want to minimize the loss. So from the same available land, from the same available resources, we want to increase the profit. So this is what is the basic aim with which we can start. So satellite and drone data again is very important. Recently, before few years, so we are connected to ISRO for some of the other projects, but there was a call from ISRO about a workshop, or we can say similar kind of training program and satellite for the agriculture application. So I was a bit concerned regarding why ISRO is taking a lot of interest in it. But after attending the program, I have even given the links here in this particular PPT also. Those interested can go through further. So ISRO is playing a commendable role in, again, agricultural area. So where find high resolution images are made available, vegetation indices or crop health and biomass. So there are many parameters, even pest and disease detection, wherein you can use the satellite data. And they have provided a platform using which you can definitely try to understand many parameters, and somehow this will help us improve the crop yield. Then there is livestock data. So again, agriculture, when we say agriculture, it is not only farm or producing the things. So there are some allied things like livestock is one of the important parameter which comes along with the farm. So animal health and nutrition or movement patterns, milk and meat production rates. So all these things, again, animal disease monitoring. So this also becomes one of the integral part of the data, which we are saying as the data where AI is to be applied. So environmental data is definitely important because nowadays there are many greenhouses. Greenhouse gas emission is one of the, again, concern to the environment. Deforestation or land use changes. All these are the parameters which are, let's say, affecting biodiversity, affecting our environment. So this is also to be taken care for our generations to come. Now, all these points which I am covering here, or I'm calling them as a data, can become one of the research topic. Like you can still research on many of these parameters, and still it is in demand, or every parameter here is equally important. Then another important parameter is the market data. So demand and supply trends must be known to you while producing something in your farm. So the harvest date should match with the demand cycle. So if you are harvesting something and if the cold storage is not available for you, you will be losing your data. So availability of the cold storage or availability of the demand in the market is equally important when you are trying to harvest your data. So if this is not known, definitely after a good harvest also farmer may lose something or will not get the profit as it was predicted at the beginning or as it was forecasted at the beginning. So this is again an important thing wherein we can help farmers, we can create apps, we can do research on this particular thing and somehow help farmers so that the farmer can harvest at the time when we have the highest available rates in the market. So in addition to that, there is a data which is available as yield trials for new crop varieties. As the research continues, definitely every day we see some new crop varieties coming into the market, some new rice varieties, some new wheat varieties, or some fruits varieties. So all these are the result of research which is done in many of the agricultural institutes. And these institutes, they make the data available so that others also can take benefit of it. Others also can work on it. And definitely this is sometimes it is available at some cost or sometimes it is available freely. Similarly, disease and pest resistance studies so that you can find out new fertilizers or new pesticides, and with the minimum use of pesticides, you can control the diseases. So again, a research topic wherein you can not only finding the diseases, but finding the solution or remedy on it. Then, as I said, this remote sensing data. So ISRO is helping us a lot in giving these data. So land surface temperature or enhanced vegetable index or NDVI, which is normalized difference vegetation index. All these parameters can help us take some of the decisions like crop classification and area estimation. So all these things, they are related to each other. So as I was talking about the ISRO workshop, which recently I was able to attend. So this is a Google Earth Engine, wherein I have given here the link. You can go through it afterwards and try to find out the space technology in agriculture. So space technology or ISRO is also playing a wonderful role in generating the data. So this data is to be used for the purpose. This data is to be used so that you can create some application. This data is to be used so that you can help farmer in predicting something. Where number of applications are given here, crop area estimation or land monitoring, pest detection, then soil mapping, horticulture. So many applications and the soil quality, all these things again can easily be done. So the data is available on Google Earth Engine. You can go through this YouTube link, or if those interested, I have the complete links related to this data, how AI can be applied, how ML can be applied to the using the Google Earth Engine. So now the second question is, what is to be predicted? So what all are the parameters which you can predict? Which is there any noise in between?
support তাহলে আমি কোন জায়গাটা জীবন দিতে হবে রেকর্ড দেওয়া লাগবে
Ma'am, I have just unmute yourself. Ma'am, unmute yourself.
Yes.
Yes.
So I guess there was some noise, some mic was on. Okay. So now we have to see what is to be predicted. So there are many parameters which you can predict the data we have seen. So there is a lot of data. Using this data now we can see what we can predict. So first out of that is the crop yield, which we have seen is the main parameter which we want to improve or which we want to increase. So crop yield prediction, definitely by optimizing the resources, by planning storage and distribution, identifying high performing crop varieties. So all these things can help us get more profit. So for that, you need weather data, soil characteristics, crop type, historical yield data, satellite or drone imagery. So all these things can help you in crop yield prediction. Then is the pest and the disease outbreaks. So in order to detect again the pest or the disease outbreak, again, all these can become the problem statements for research. First is early intervention with pesticides or biocontrol methods. So as use of pesticides is not assumed to be good for human health. So how we can reduce? So early detection of pest or disease outbreak can help us use minimum pesticides to control the outbreak. Reduction in the crop losses and the input cost. Again, for this, you need temperature, humidity, or NDVI, which I said we can get from ISRO, is the data which you can use for pest even detecting the outbreak. Okay. Then the market price and the demand prediction. As we want to give highest profit to the farmer, it's necessary that you understand the market, you understand the market price, or you understand the demand from customer. So estimate the future prices of agriculture commodities and consumer demand trends. So in order to optimize again the price which a farmer is getting, we can use the historical price data, trade trends, or consumer preferences. And accordingly, if the farmer is harvesting his produce or deciding the plants to be produced in the farm, the profit can be maximized. Then optimal planting and harvesting times. So again, for the same reason, to get higher cost, you have to optimize the harvesting as well as the planting times. Then weed growth and a spread. So weed which affects the original plants is to be eradicated or is to be removed from the plant as early as possible. So predicting the weed in or growth in the field using field images, historical weed data, again weather data, can help us to get rid of the weed so that the less efforts are required while producing the crop. The livestock or the health productivity. Again, the livestock, as we have seen, is the part and parcel of a farmer's life. So animal health records, environmental condition, feed quality can help us improve the livestock health, or we can say productivity. Then harvest quality prediction. This is again a research topic wherein you can try to predict the harvest quality in order to meet the market standards, in order to have the premium quality produce so that we can export it, we can get more profit out of it. So again, for this also you need profile data, environmental condition. Nowadays, even latest technologies are used so that you can find out the journey of a particular produce from the seed itself to the dining table. So blockchain is one of the technology which is used nowadays, even in the farm produce, so that whatever you eat, you know the sources from where it has come, the way which, from where it has traveled, from whether the wheat you are using for making your chapatis has come from Gujarat, or it is from Andhra Pradesh, or it is from somewhere else. So blockchain technology is helping you in this particular regard as well. So harvest quality prediction is also one of the sustainability matrix. Again, the last or most important parameter, again, we can say is we want to take care of the environment also. So reducing environmental footprint is also one of the very important research topic. So data needed, again, resource usage data, satellite imagery, or farm management practices. And you can achieve the sustainable farming through it. So post-harvest loss prediction. So post-harvest loss prediction, as we just discussed. So if the cold storage is now not available for your produce, and if the produce is perishable, definitely you are going to lose it. So while producing or harvesting your goods, you should know the availability of the storage infrastructure, or you should know the streamlining logistics to minimize the waste. Again, the data needed will be temperature, humidity, supply chain records, or storage conditions. So all these things are the inputs. Like say, first we have seen the data, then we have seen what is to be predicted. And all these things are going to help us in making agriculture sustainable. So now we'll just see a look at the major transformation which has come in agricultural, let's say in last 10 years. We can call it as agriculture 4.0, as we have industry 4.0. Similarly, we can call this as agriculture 4.0. Till in the agriculture 3.0, there were machineries like tractors were used, or many of the machineries were used in the agriculture field. But with agriculture 4.0, now it has become a digital agriculture, or we have the IoT extensively used in agriculture. We have automation and robotics used extensively again in the agriculture. We have agricultural drone technology, again, for many of the reasons, for spraying or for monitoring the crop health. For many parameters now you can use it. Vertical and urban farming has become part and parcel. Definitely you call it urban farming, but still urban farming or vertical farming can again be there in the rural areas also, where the land is there. So the land, when we say the produce is much dependent on the weather conditions. If in addition to that, you have some area where you have vertical or urban farming, at the same time, you can achieve higher yields. So precision farming, use of robotics and automation has allowed us to go with the precision farming. And in addition, the geographical information system or aerial imaging is also helping us in, we can say, securing your farm. So earlier it was a small scale farm with no data records, or manual labor and hand or animal power, or farmer's experience. Definitely it was good, the experience which a farmer has. We want to make AI, we want the AI to learn from the experience which a farmer has, because finally AI is also learning from the experience, and a farmer who is farmer for the generations together, he has the knowledge which definitely you cannot find in the books as well. So while I would say, while making a expert system or AI, which we want to give us good decision, in addition to all the data which we have just listed, the experience of a farmer, old farmer who has worked for years together in his farm, can be very much helpful in training the models. So this was the old farm. Now the smart farming has Internet of Things, as we discussed many times. So sensing, many sensors are there in the farm. So this is creating big data. Robotics applications are there, automated equipments are there, and in addition to that, the satellite image and positioning is helping us take the informed decisions regarding the sowing of the seeds, the quality of the seeds, or the time to harvest the data. So as I was talking about the progression, so this progression is from architecture, agriculture 0, 1, 2, 3. As I said, in 3, we started using many of the machineries, but in agriculture 4, now it is system of systems, or we have use of IoT, which is creating a lot of data, which is allowing us precision farming, or which is helping farmers in number of ways. So precision farming, again, I came across a term and found it very interesting. So I have mentioned it here, which is called as precision farming as a SaaS, or as a software as a service product. So farmer need not worry about it. It is given as a software as a service. The apps are available. You can definitely outsource this particular work of applying AI to your agricultural farm. So it has become a SaaS product, or software as a service product. Okay. So moving ahead, so now we'll try to understand how this is done. Or so integration of AI in agriculture has the potential to transform agriculture. As we have seen, there is a lot of data, and there are a number of things to be predicted or forecasted, which can help us improve the agricultural yield. So integration of AI is assumed to be important here. So by analyzing the data from various sources, AI can help farmers make data-driven decisions. Data-driven decisions, most of the times we say these decisions are correct. So we can optimize the resource use, we can reduce the environmental effects. So according to World Economic Forum, it is reported that AI integration in agriculture could bring 60% decrease in pesticide use, definitely very good for the humanity, and 50% reduction in wastewater. So in addition to increasing the yield, in addition to increasing the farmers, it is helping us save the environment as well. So we can save the soil by reducing the use of pesticide. We can save water by reducing the use of the water resources. So database decisions, they are allowing cost savings. So definitely more profit is earned. Automation impact, reduced pesticide use, improved health, soil health, and reduced water usage. So there are many applications which we have discussed till now and are listed here. So optimizing automated irrigation system. So irrigation is the first part of any of the farm. So optimizing the automated irrigation system, we can definitely use the basic regression algorithms or basic AI/ML algorithms to optimize the use of irrigation. Maybe IoT is used there, so you can have sensors to check the soil and then automate the irrigation system. Detecting leaks or damage to irrigation system. Crop and soil monitoring, detecting disease and pest, monitoring livestock health, intelligent pesticide application, yield mapping and prediction analytics, automatic weeding and harvesting, sorting harvested produce, and the surveillance. So these are few of the, we can say, applications wherein AI can become a part. How this is done? So you have the crop, you have sensors placed in the farm. From these sensors, you are getting the data on a particular software platform. That data you can either send to cloud or you can analyze this data at the edge also. Both these things are possible. Either you go to cloud and analyze the data, apply AI/ML algorithms. Nowadays, even deep learning algorithms are used wherever you have the data in the form of images. Then take informed decisions and the actuation can be done. In another way, it can be seen as this image. It's like you have the data acquired from sensors. You have the data, as I said, from the external sources. Many of the external sources like the quality of the seed or the information regarding weather forecasting, the possibility or the data from the market requirement. So all these become the external sources. Then you have sensors in the farm. Then there's a gateway for data transmission. You are processing the data. As I said, I can transfer the data to cloud and store it in the cloud for further studies. I can process the data. I can apply AI. So AI algorithm can be trained on the data which you are getting here. This can help you in reasoning, and you can create a HMI or human machine interface, a app or a web platform. And depending on the decision, you can control the actuation. So all these things can be done if you have the data in your hand. If you have the data in your hand, you can process the data. Any of the algorithm, there are n number of algorithms used for clustering, classification, regression. All these algorithms which are used in general application are applicable to the data which you have here in agriculture case. You can divide the data as the pre-harvest, the harvest, and the post-harvest. And depending on the stage at which you have the data, you can use it for application, like for soil analysis, weather forecasting, crop monitoring, irrigation management, yield prediction. These are all pre-harvest application. For harvest, you need optimal timing. So optimal timing prediction for harvest is one of the basic research area. Then autonomous harvesting, how it can be done, crop sorting, grading. So all these topics mentioned here again can become a topic for research. Supply chain optimization, quality assessment, market analysis, processing the automation, waste management. So all these are the applications which we say post-harvest. So it's not only the harvest, it can be pre-harvest, it can be harvest, and it can be post-harvest. In all the areas you have the data, so you have the AI applications to be applied. So just now as we discussed, so IoT is playing an important role in crop yield analysis, auto spreading, auto dosing, it is again called diagnosis of diseases, variable rate, water stress, field monitoring. So all these applications, they come under IoT, which is transforming the agriculture sector. So as again can be seen from these pictures, so the drones or the quadcopters, they are playing an important role in analyzing. Just the drone is trying to find out whether there is any kind of disease on the farm, or it is helping in killing the weed which is affecting your farm. And then is the vertical farming or the urban agriculture, to which will come in some time. A very important topic once again. So I must talk about some of the initiatives of Government of India also, wherein you can see our Prime Minister helping farmers. So this is Drone DD program, wherein a number of quadcopters or drones were given to women farmers, and along with that, the trainings on how to use it was also given. So we are progressing in this field. So as drones are used, definitely the intelligent use of drone is expected, or the drones itself are using edge intelligence. Some AI algorithms are running on them. They are helping in many of the ways. So lot of data is generated, and it's, as an engineer, it's our duty to definitely help in improving the quality. So there are many uses where drone is used, or drone has advantages in agriculture. So we can definitely avoid the chemical overuse. Just using a camera on drone, you can find out where the weed is or where the pest is, and only in that area you can remove the weed, or you can spray the pesticide so that the remaining chemicals are not used, or check the crop health. Definitely manual labor use is reduced, or we can say, or not required if doing the surveillance using camera for livestock management, for soil and field analysis, for plantation, for monitoring the growth, or prepare the weather glitches. So for many of these parameters, for geofencing as well, you can make use of drone in the agriculture. And that is definitely creating a lot of data. This data can be definitely analyzed, and we can make the use better and better every day. So as I said, AI can tackle the labor challenge as well. So it can solve many of the problems of a farmer. In addition to this, now we should see this is all possible. There are a lot of data is available. AI ML algorithms are readily available. You just ask ChatGPT, and the algorithm on your data is ready for you. So many algorithms which are off the shelf, which are already available, you can use the data. You can predict something. You can definitely use the algorithm for forecasting something. But the challenges which are there while doing it is the limited data availability. So lack of historical or real-time agriculture data in many regions. So this trend has become very much in practice, has come in practice since last 10 years, not more than that. So we have limited data availability. Sometimes there are incomplete or inconsistent data sets for specific crops and conditions. Like you may find some data for one particular region, but not for the other region. And when it is up to analyzing something or predicting something, you need to have the local data as well. So the data has to be region specific. So creating more and more data sets is again a challenge or a research problem. So data quality, noise, errors, or gaps in agriculture data can affect the model accuracy. So if there is a noise, or if there is an error, or if the data is not recorded properly, it can affect the model accuracy and will not solve the purpose. Then infrastructure limitations. So in the rural area, still we are trying to find out internet connectivity, at least in the area where the farm is there nowadays. In most of the villages, we can see the internet connectivity. And the advantage in India, we can say that nowadays every farmer also is using a smartphone. Everyone is using a smartphone, and the internet is all connected. But still there is a lack of access to advanced sensor, drones, or IoT devices. This again initiates new business ideas like drone as service, or the agricultural machines as a service, or IoT devices as a service. So only sensor can be there in the farm, and the other the controllers and everything else can be used as a service. So many, again, business opportunities will come out of this data, will come out of these concepts. High cost. So advanced AI tools or hardwares are expensive for small scale farmers. So that's why I said to take care of that, we have the software as a service or drone as a service or IoT devices as a service concept coming into picture. Scalability issues. So AI solutions may work well on small farms or test plots, but face challenges when applied on large scale. Third is farmer adoption and awareness. So due to lack of technical skills. So here comes the again role of a teacher, or we can say researchers to train. So VR, AR like technologies are coming into picture or helping farmer to understand the technological changes. There's some resistance to change or trust in AI, less trust in AI, but this is a timely hurdle. Definitely everyone is going to accept the use of AI in agriculture as well. Integration challenges, lack of interoperability, difficulty in integrating AI system with existing farm equipments. So if you have a tractor which is not AI enabled and we want to make it AI enabled, definitely we need to think of the interoperability. But still, yes, this can also be a research problem, but it's not undoable. So you can easily do it. You can integrate the existing technologies to the already available farm equipment. Economic and financial barriers. Yes, the initial investment may be more, but again, to every problem, there is a available solution, or every problem becomes a research problem. Environmental challenges are always there. Number of times in Pune, we have experienced where whenever the possibility of rain or a red alert is issued by the government, the holiday is declared in Pune, and then on the next day we don't even see a drop of water or a single raindrop. So predicting climate is again a challenging area. But still, you can say that nowadays predicting a red alert for a particular day may be a difficult challenge, but predicting the weather across a week or across a month has become very accurate. And even predicting that for a particular day is not that important. Definitely, sometimes it may harm your. So if it is a harvest time and there is a possibility of red alert, and it is known to a farmer well in advance, care can be taken. So again, few more challenges here you can say are the algorithmic and the model challenges. So overfitting and the bias. AI models trained on limited or the biased data sets may not generalize well to other regions. So let's say you have the data related to Maharashtra region and you're applying it to Madhya Pradesh or you're applying it to Andhra Pradesh. Your AI model will not be. There are techniques like transfer learning where your trained model can be again retrained, or at least you can change few of the last layers of your model using transfer learning for that particular region. But still, this is a challenge. Lack of explainability. Farmers and stakeholders may find it's difficult to understand AI. And definitely dynamic agricultural systems. So now there are new pests coming into picture because of one or the other reason. So you need a model which is very strong and which is helping you in improving the yield or reducing the damage to the farm. So in addition, there are issues like standardization or IPR issues, clear regulation in use of AI. But again, this is, we can say, a problem which time only can solve. So again, I like this particular term, which is called as drone as a service. So you may have any of the agricultural equipment, which is costly, can go as a service and help farmer to use it. So in this case, new business opportunities are also created, and at the same time, it is going to benefit the farmer as well. Now we'll come to urban agriculture. Before that, I would just, in order to summarize what we have seen till now, I would like to play a simple video, and maybe it will help me take a break of 4 to 5 minutes, or I guess it is 4 minutes video, and it's a video which you definitely can enjoy. So I'll play the video. Just let me know whether the audio is, you are able to hear the audio or not. Just a second.
Of discovering the latest AI technology
audible.
Yes, it is audible. Okay, so it's a 5 minutes or 4.5
being
minutes
used
probably.
in agriculture.
So wonderful
Agriculture is
video.
one of the oldest and most important industries in the world, providing food and resources for human survival. Over the years, technology has played a significant role in improving agricultural productivity and efficiency. The advent of artificial intelligence, AI, has brought about a revolution in the agricultural sector, enabling farmers to make more informed decisions and optimize crop production. In this video, we will discuss some of the AI technologies that are already being used in agriculture. 1. Crop monitoring. Crop monitoring involves the use of AI-powered sensors, drones, and satellites to monitor crop health, soil quality, and moisture levels. This technology can provide farmers with real-time data on crop growth and help them identify any issues before they become major problems. By monitoring crop health, farmers can take proactive steps to prevent crop damage and ensure a healthy harvest. 2. Precision farming. Precision farming involves the use of AI algorithms to analyze data on weather patterns, soil quality, and crop growth to optimize planting, fertilizing, and harvesting. This technology can help farmers optimize their crop yields and reduce waste by identifying the best time to plant, fertilize, and harvest crops. By analyzing data on weather patterns and soil quality, farmers can also make informed decisions on the type and amount of fertilizers and pesticides to use. 3. AI in livestock farming. Livestock monitoring involves the use of AI-powered sensors to monitor the health, behavior, and feeding patterns of livestock. This technology can help farmers identify any health issues before they become major problems and optimize feed and water usage. By monitoring livestock behavior, farmers can also identify any issues with feeding or watering systems. AI technologies can be used to farm waste management, in feed management, and to milk the animals. 4. Crop and soil analysis. Crop and soil analysis involves the use of AI algorithms to analyze data on soil samples to determine nutrient levels and recommend optimal fertilizer use. This technology can help farmers optimize their crop yields and reduce waste by identifying the best type and amount of fertilizers to use. By analyzing data on soil quality, farmers can also make informed decisions on which crops to plant and how to manage their fields. 5. Crop forecasting. Crop forecasting involves the use of AI algorithms to analyze data on weather patterns, soil quality, and crop growth to forecast crop yields. This technology can help farmers plan for the future and make informed decisions on when to plant and harvest crops. By forecasting crop yields, farmers can also make informed decisions on which crops to plant and how to manage their fields. 6. Weed and pest detection. Weed and pest detection involves the use of AI-powered cameras and sensors to detect and identify weeds and pests in crops. This technology can help farmers take corrective action before the damage is done and reduce the amount of pesticides used. By detecting and identifying weeds and pests, farmers can also make informed decisions on which crops to plant and how to manage their fields. 7. Irrigation management. Irrigation management involves the use of AI algorithms to analyze data on weather patterns, soil quality, and crop growth to optimize irrigation schedules and reduce water waste. This technology can help farmers optimize their water usage and reduce costs by identifying the best time to irrigate crops. By analyzing data on weather patterns and soil quality, farmers can also make informed decisions on when to irrigate and how much water to use. 8. Harvesting. Harvesting involves the use of AI-powered robots to harvest crops, reducing the need for manual labor and increasing efficiency. This technology can help farmers save time and money by reducing the need for manual labor and improving the quality of the harvest. By using AI-powered robots, farmers can also reduce the risk of injury to workers and improve safety in the field. 9. Pollination. Pollination involves the use of AI-powered drones that can mimic the pollination behavior of bees. These drones are equipped with cameras and sensors that can detect flowers. In conclusion, these technologies have the potential to increase productivity, reduce costs, and optimize crop production. AI technology is transforming the agricultural industry and holds great potential for the future of sustainable and efficient agriculture. That's all for today's video on artificial intelligence.
So this was a very interesting video which I found related to the technology. So, and it was summarizing what we discussed till now. Next, again, we'll switch to a topic called as urban agriculture. Just give me a second. I hope the slide is visible now.
Yes, ma'am. Yes.
Yes. So urban agriculture, which involves initially or started with horticulture or the greenhouses, which we have seen. So in greenhouses where you have the controlled environment, applying AI becomes comparatively easy. So crop yield prediction and price forecasting, intelligent spraying, crop and soil monitoring, horticulture robots, predictive analytics, disease diagnosis. So all these are the applications which you can use in the horticulture, where we have the control environment in which you have the sensors applied, the farm data is available, agriculture marketing data, soil data, everything is available. You have the cloud computing, you can use the data and for actuation. So you can use AI in horticulture. In addition to that, nowadays we can see many of the apps available. Like I have taken one of the example of Shetkari Mitra, which helps farmer in many of the ways. So this is again a area where many such apps are available, maybe in the regional language. I have taken here example as a regional language app, but converting many of the apps into regional language is also one of the area. Like this is another application, Agri AI, where it's using in smart farming advisor. So this app in English can definitely be converted into the regional languages and can be helpful to us. Agrio is again one of the application or one of the app available which farmers can use. Let's look into some of the data sets which are available. So for crop monitoring and disease prediction, DigiCrop, crop yield data set, or International Crop Research Institute for semi-arid tropics. All these data sets are easily available, which can help you in writing your own algorithms, making your own algorithms, or analyzing your data. Then for pest and disease management, one of the well-known data set is Plant Village data set, which has a large connection of annotated plant disease images for AI-based pest and disease detection. It covers crops like maize, potato, or it's now available for many of the crops. PestNet dataset again provides you the pest monitoring data. Open aerial map is the satellite imagery data available, which again can be used for research purpose. In addition, remote sensing and satellite imagery data is also available. Landsat data is quite helpful to us, which you can use for many of the application, or again, high resolution satellite images are available from European Space Agency. And these images can help us in taking some informed decisions, like again, with the purpose of improving your yield. Indian Meteorological Department also has made the data available, which again is related to regional weather or climate data sets, especially for India, includes the rainfall, humidity, and temperature patterns, which again can become part of data in your AI algorithm. In addition, regional database like ICAR, Indian crops and soil types, or regional agricultural practices also is helpful when you want to start some work in this particular area. Okay, now I just want to give a brief look on the work which we are doing at MIT, research which is funded by one of the industry under CSR project. So as it is under CSR project, we still do not have permission to disclose the industry, but it is a project funded by industry. Under CSR, we have received around 68 lakhs, out of which around 18 lakhs are used for development of test bed for intelligent hydroponic system. So hydroponics, if you have heard before, is a part of vertical farming, or we can say urban farming or controlled environment agriculture, which is soil-based farming. So there are many issues or many problems related to the conventional farming or the soil-based farming, which we have just seen. So in order to overcome that, we have started working on the soilless farming. We had opportunity to visit Dubai for Dubai Expo, wherein we could see very good example, very good development on the hydroponic systems. Many demonstrations were arranged or organized in Dubai Expo. And this is the one which clicked us. So we started working in the direction of intelligent hydroponic system or the soilless farming. So in short, I'll try to explain, won't take much time. So I think I have 15 more minutes, or I'll continue for 10 minutes, 5 to 7 minutes more. And then if there are questions, we can take few of them. So development of test bed for intelligent hydroponic system. Hydroponic, as I said, is a soilless farming. So we started with the aim of designing the framework that includes sensing, monitoring, and control, set up communication module, assessment and analysis of crop growth characteristics with nutrient management, and AI algorithms to predict and improve the quality. So this is what is called a hydroponic setup. There are many available setups, like one of them is called nutrient film technique, where only the film of nutrients or the required nutrients for the plant, which definitely includes NPK, they are added to the water, and that water flows throughout the test bed. Throughout this pipe, the water flows. Only the film of the nutrient is given over the water. And that film helps the farmer or helps the plants to get the nutrients, and only water, nutrients, and sunlight. If the sunlight is not available, you can even use the artificial lights so that the growth is monitored 100%. So in Pune city, at least, there are many places where we have the hydroponic setups. So we visited many of the hydroponic setups to see how they grow the farms, or what are the challenges they are facing, or what are the techniques they are using for. So one of the type is called deep water culture, wherein the water is not flowing, or nutrient film technique where the water is flowing continuously. So we could find both these techniques very interesting. And then there is third one, which is called Dutch bucket. So this is again the system where you can see our students, they are taking some readings or photographs of the, again, the part of data generation. So where the strawberry is planted in the hydroponic setups, and we are monitoring growth, or we are seeing the growth, or we are trying to analyze the growth patterns. So in order to understand it better, even you can see a few of the photographs from our lab, or I can say these things are there in our infrastructure or MIT, wherein we have the setups which are called deep water culture. This is a setup where instead of using the sunlight, we are using, this is called grow lights to grow the plants. These are the nutrients which we are using for the proper growth of the plants. And we are generating data. We are trying to analyze the nutrient quality, or we are trying to find out the pH of the water, the TDS, which is called total dissolved solids, which decides the amount of nutrients which are there in the water. So we are measuring these things day to day, and then monitoring the growth of the plant. So we are generating the data. First data is the image data, which we are monitoring the growth continuously. Secondly, we are generating the data in the form of Excel sheet, wherein we are trying to find out the height, the growth in the form of height of the plant, the growth in the form of number of leaves which are coming to the plant, or the number of leaves which are becoming dead, or we are trying to understand. So in the process, when we started doing it, we could see that this hydroponics is said to be done in the controlled environment. The vertical setup, which you can see, is called a nutrient film technique, where only the water flows over the plant, and that helps the plants grow. But in this process, we could see that, so in our lab environment, we were not able to maintain the temperature, or at least on Saturday, Sunday, we used to switch off the window or switch off the lights and the air conditioner. So it gave rise to some of the diseases. Then we decided that we'll try to analyze this also. So when you start something, or when you try to research on one particular topic, as a byproduct, we come across number of other issues or number of other problems, and then it becomes again a research problem. So at present, there are okay. So in this journey, initially we did some sensor or use some sensors like sensor fusion for environmental monitoring, energy efficient LED light control, automated pH regulation, intelligent ventilation. So we can say generating the data by doing some simple problem statements. So integrated climate control system, nutrient adjustment based on comparative sensor data. And through this simple experiments, we could generate a lot of data. And as I said, at the same time, we were measuring the length of the or height of the plant, the number of leaves. So this data was also recorded as a growth data. Now, when you have data, it's in your hand to use it. It is in your hand to use the off-the-shelf algorithm, or you may modify the available algorithms and create your own. So now, as in this process, I said, we came across some of the diseases which are coming onto the hydroponic system. So we analyzed the type of diseases. the soil-less farming has the diseases which are generated by soil or soil generated. But at the same time, the hydroponic, which is soil-less farming, this also has the diseases, maybe fungal diseases, basically because we are using water continuously, some of the bacterial diseases, some of the viral diseases, and then there are again pest related issues. So we studied in detail the type of diseases which can harm to your hydroponic setups. And then we thought we'll go deep into these diseases as well. So we generated our own data set. We visited few of the hydroponic farms. From there, the data was collected and then, as I said, there are a number of already available algorithms. So you must have heard about YOLO, which is you look only once, which is the algorithm used for many of the object detection tasks. So after generating our own data set, after labeling the data set for the particular type of diseases, we use the YOLO model. And using YOLO model, we trained YOLO model. We use both YOLO V8 and V9, the versions which were there in use at that time. Now, even YOLO 10 and 11 has come, on which our next batch of student is working. But we work with YOLO V8 and V9, and we could convert the model. The trained model was converted into an app, or we used it from an app. And on the same setups, we were able to identify the diseases accurately. So starting with the data, starting with the collection of the data, then augmentation of the data, labeling of the data, use of the off-the-shelf algorithm. As I said, initially you need not write your own algorithm. There are n number of algorithms which are available. What is important is to have the data. Data should not have any bias. The data should be as large as possible if you want to use the deep learning, or even simple machine learning algorithms also can be used. Proper labeling of the data, then use of the model, and then you have to test the model. So we tested the model and we could see that approximately same accuracy was obtained for YOLO V8 as well as V9 model. And we were able to detect almost all kind of diseases which are possible in the hydroponic setups easily. And this comparative study, finally we came across, like, as compared to V9, V8 will be useful for us because we want to port it to a portable device, and V9 was taking more time for training, as well as the inference was also taking time. So as compared to that, V8 we found beneficial, as we want to port it to either a device like Raspberry Pi or a mobile device. And the final conclusion was done, and we could publish the work on comparative analysis of V8 and V9 models for real-time plant detection in hydroponics. So this is the journey which we did. Now, at present, again, we are working on again another kind of hydroponic, which I said is called the Dutch bucket system, wherein again we do not have soil. So what you are seeing here are the we can say stones or hardened soil. So it's not soil. The water continuously flows through the system, and this time we are working on Turkish cucumber, wherein we have seen that very few of people have worked on it. It has got very good growth rate, many good, the yield is very good. But at the same time, while after visiting the farms, we could see that there are a lot many diseases, or this time instead of diseases, we are trying to work on the deficiencies. Let's say due to deficiency of some of the nutrients, either potassium, phosphorus, or any other kind of, again, micronutrient, which is not given to the plant, and because of that, it is creating some deficiency. So in addition to diseases, another thing which affects the yield is the malnutrition or imperfect nutrition. So this time we are working on this Turkish cucumber, wherein we are trying to understand the deficiency, the growth, and the effect of the nutrients. So we are having generating the data of nutrients given to the plants, and will definitely have the growth depending on the nutrients, and will generate the model, or to some extent we have done it on using YOLO 11. In addition, in this process, which I said, we were able to find many of the deficiencies or many of the pest attacks in the atmosphere where we were trying to grow the plants. So initially we started with polybasil, we started with spinach, but the growth was not sufficient because the amount of light in our lab was not that good, and controlling that was not very easy. So another idea which came to one of us was to grow the colocasia, and you'll be surprised to know that we are able to grow it very fast. So as compared to the soil or the farm, this colocasia growth in the controlled environment is much more. We are generating again the data for that regarding how the growth happens, or depending on the nutrients, depending on the pH value of the plant, and the temperature, humidity. Simple devices, simple DHT sensor, simple pH sensor, which you can even see here, is helping us in generating the data. We are sending the data to cloud, or simple things, Pick Cloud is used for doing that. Again, on this Turkish cucumber, using RoboFlow, we have created the app wherein you can easily find out, like in this case, there is a calcium deficiency, or here there is boron and potassium deficiency, or these are the healthy plants. So we are able to get very good accuracy, around 90%, while from the data set which we have generated, and still we are testing it on the same data. Definitely we have now the plan to switch to some other data sets. Similarly, we worked on basil. I think I should speed up because it's already 7:30. And so simple experimentation can lead you to give the data, and using this data, you can try to build your own models. Again, the simple hardware which you can see using the Raspberry Pi and ESP32 to control many of the actuators and sensors. So controlling pH, controlling the NPK is possible. First thing which you need is the data. So here the data which we are getting is from the sensors. So I think I should stop here. Some of the plants which even we are growing at home as a hobby on the same project, and we could see a very good so soilless farming example. Simple node MCU based circuit to control it, wherein you can save the water, you can save the energy, and at the same time you can grow the plants. So I think I'll stop here, and if at all there are questions and Praveen sir is allowing, we'll take few questions, or otherwise I would like to thank everyone for listening to me.
Thank you,
Yes.
ma'am. Yeah.
Yes.
Okay. I request if the participants have any questions, they can unmute themselves. We'll take one or two questions and then we'll go to another session.
Or else I'll share the PPT. I'll share the PPT. You can share it with the participants, and those interested can ask the question afterwards as well. And
Yeah,
yes.
sure. So is there anyone who would like to ask the question? Okay, so
Yes,
Actually, earlier there was different questions.
yes. So I hope
Yes, ma'am.
I can see one of the question how AI can minimize the use of pesticides. So as we have seen in the video also. So if you are able to see the pest in the initial phase, in the very initial phase, if you are seeing the pest, detecting the pest, the use of pesticide is definitely reduced. And AI can definitely help find out the pest early stage. So if you are able to find the pest or diseases in the early stage, you can definitely use AI algorithm.
So thank you,
So
ma'am.
thank you all.
Yeah.
So I'll share the PPT, which can be shared with the participants. Yes. So
Thank you very much, madam. Very nice and informative session. Thank you very
Yes.
much.
Thank you. Thanks, your college authorities. Thank to Praveen Wankede sir, Bhuyar sir, for giving me the opportunity to talk on a topic which is very close to my heart. Yes, thank you.
Thank you, ma'am.
Yeah.
It is a wonderful lecture that you have given. So starting from how the data can be collected, what type of different data sets that you can collect, and you are also given the different use cases, how the data predictions and forecasting can be done. You also given a very good example of how AI can be used in horticulture. So I hope and different research topic also you are suggested. So I hope all the participants will take the help of these research topics and they can uh, use this research to improve the quality of the farmers. So thank you, ma'am.
So I'll stop share and yes,
Yes.
yes, thank you. Thanks once again.
Thank you all the participants. Now we'll move ahead with the next session of this day 2 session. So we have the second session for this today's. We have Dr. Shrikant Rupavataram sir is there. Sir, are you there?
Yeah.
Yes,
Can I
sir.
share my presentation, please?
Yes, sir. I have made the co-host. You are
Okay.
able to share.
Yeah. So hope you can see it and hear me too.
Yes, sir.
Yeah.
So your presentation is clear. Your
Yeah.
video is also clear, sir, and your voice is clear and audible.
Yeah. Thank you. So the topic
Yes.
given to me is actually, if you
Sir,
want,
just-
okay, sorry. Yeah.
Yes, it's there. So thank you all. Today we have very great personality who is going to deliver the session on digital agriculture initiatives for data-driven farming. And the expert is Dr. Shrikant Rupavataram sir. Let me introduce him. Uh, Dr. Shrikant Rupavataram sir leads the digital agriculture initiatives and heads the IHUB International Crop Research Institute for the Semi-Arid Tropics innovation platform for agri-tech startups. Mr. Shrikant is a senior scientist in digital agriculture cluster of a global research program, Resilient Farm and Food Systems. He holds a PhD in post-harvest technologies from Massey University, New Zealand, and a master's in the same field from Rethel College, University of Essex, UK. He is a Marshall Pepworth Scholar and a recipient of the prestigious Gardner's Prize in the year 2005 for the excellence in the field of horticulture from the Worshipful Company of Gardeners, London. Mr. Shrikant received Ellen E. Atkins PhD scholarship to undertake doctoral study and awarded by the Global Challenges Research Fund sponsored David Livingston Fellowship from the University of Strathclyde, Glasgow, UK in the year 2020. Shrikant has over 23 years of rich experience in implementing agriculture research and development projects. He has worked in diverse cultural backgrounds in the United Kingdom, Africa, Oceania, New Zealand, and the India, and has over 25 research publications to his credit. Mr. Shrikant has expertise in conducting quality assessment using non-destructive techniques and eliciting digital agriculture strategies for agri-tech startups. Mr. Shrikant is experienced in process engineering innovations using artificial intelligence, UAVs like drones, modeling and big data analytics for decision support in crop nutrition and protection. Mr. Shrikant likes his work to impact smallholder farmers by building their capacities through innovative digital tools for agriculture, extension and management. Uh, we have a very so many achievements to his credit, so I just want to stop here because we want to listen to sir. Sir, you can start with your session.
Yeah, thank you. Thank you for reading out the entire bio. Uh, Topic is very pertinent actually to the times we are in because everybody's talking about AI, ML, and because digital agriculture, because agriculture is one of the last sectors that has got influenced by what's happening in the tech world. So I will go to the next slide. For those of you who do not know, International Crops Research Institute for the Semi-Arid Tropics, it's the only CGIAR institute, consultative group for international agriculture research. It's a United Nations a mandate for us. So we work in those areas which are all orange. So these are semi-arid tropics. So many people live here, more than 2 billion of them, and most of them are poor with high levels of poverty, malnutrition, and environmental degradation, especially lack of water and also poor soil qualities. We have a mandate, like every institute. We are a crop research institute, so our crops are dryland cereals. We call them pearl millet, bajra, sorghum, jawar, and finger millet, ragi. And among legumes, we call them legumes because they are very intense in proteins, chickpea, pigeon pea, and groundnut. Of course, groundnut has oil content also. Last year, we celebrated International Year of the Millets, and ICRISAT played a defining role for all the most of the FAO related programs around the world. So we took lead in that. And if you're wondering where I am located, I am in Hyderabad. Thanks to the late Prime Minister Indira Gandhi, who gave this around 3,500 acres of land in pristine location within Hyderabad city limits. Actually, it is like if you can carefully see the top right picture, there is a road in between. There is on the left side, you will find red soil and black soil to the right. Very few places on earth have this type of both soils adjacent to each other. It seems there was a volcano in past, and we use that for experimentation for good because we have that diversity where we can see the response of crops in both types of soils. We have 9 other locations, mostly in East and Southern Africa and West and Central Africa. So these are some of the locations. We are very diverse people having diverse topics, and agriculture seems to be the most defining thing that is happening right now. And in terms of climate, and everybody is talking about the climate crisis, the COP 2030 has just 29, I think, in Baku. It has just concluded couple of weeks ago. If you see, I just want you to think of where agriculture was and where industry was. This is about in 1780s. So the steam engine was there and the power looms came in terms of using water as power. Mechanization started a little bit, but if you see, agriculture was totally, lacking anything to do with what industry has been doing. So also, if we come immediately to the early 50s, the Green Revolution, with the advent and use of most of electrical tools, tractor being there, pesticide being applied, high intense agriculture started in those times. And one of the things that contributed was those high yielding varieties of rice and wheat. So that's the time that things were really growing big. And before that, India had food insecurity actually. So if we come, say, way back to 1990s, with the advent of electronic age, we had a lot of innovation that has been done in the industry in terms of automation and stuff. whereas agriculture was still trying to find out how yield can be monitored or how we can use the GPS system for variable rate of fertilizer application, for example. Then suddenly something happened in early 2015 to 2017. It's the agriculture 4.0 with intelligence being there. That's where we get a lot of these buzzwords that are used: smart farming, prediction, predictive analytics. Intelligence has come to be used in a greater way. I don't say whatever industry is doing, we are doing, but we have started doing a significant improvement in the applications that are coming up from the tech industry applications into agriculture sector. I don't know what is in store for 2030 or 2050, but I can assuredly tell you agriculture is going to reach what the industry is doing. It is the 5.0 that we say in the next generation work. We have carbon credits, we have works that are related to carbon farming. Things are going to change dramatically because of even regenerative agriculture approaches and stuff like that. So, a lot to hope for and look forward, but we don't know how the pace will be, whether it is 2030 we will reach or 2050 by the time these things happen. So it all depends on how the industry, agriculture industry, farmers respond to changes in the adoption of new technologies and tools that are coming up. If you are not having any agriculture background, these are some of the basic risks that exist in agriculture. There are production risks, there are post-harvest risks, there are market risks and ecological risks. Ecological risks are soil degradation and water availability is limited. This is a very popular picture that was in Live Mint many years ago. Even in University of Berkeley, we had this. I really tried to get where this picture originally was taken, but found that only in some Indian media it was already there 10 years ago, 15 years ago. The post-harvest risk is least understood. Everybody talks about market risk, but they fail to understand because most of the agriculture universities and the Indian Council of Agriculture Research Institutes focused on production risks in a very good way. And also, there is a limited thrust on post-harvest risk. Of late, it has come up in a big way because NABARD has been investing in huge storage and infrastructure in India and logistics infrastructure. But if we do not solve this storage and quality, we cannot address the market risk properly. The reason being, for example, you know how Amazon actually takes the quality assurance, but who will take the quality assurance of the produce of a farmer? It will be bulky, there will be very high costs for transport, and it may not be of the same quality by the time it reaches the other destination because of various environmental factors which are post-harvest losses. It can be due to biotic or abiotic factors. Biotic, I mean pest and disease that can eat away some of the stuff up to the extent of 30% while before it reaches the destination. Or because of the heat that is produced, fresh produce can deteriorate very fast, withering and loss of weight and also other rots happening. So these are the things that should be kept in mind if somebody is thinking about agriculture as a sector, because it is a very high risk sector. And the risk is actually taken by the farmer. But after the harvest, the other things that happen from the market onwards, the fruits of the labor of the farmer is actually more fetching to the other intermediaries in the value chain. So that's the real thing. We all talk about farmer being in the center. There is so many people working with them these days. And not only these days, it's been like this for a pretty long time. There are marketing agents of different private companies, the KVKs, the agriculture institutes and state agriculture universities and ICR institutes and research institutes like ours, also participating in reaching out to the farmers with advisories. And then the government departments are there, agriculture department that itself has the highest number of feet on ground extension workers in the whole system. So everybody has a different motive, if you see, in this whole ecosystem. So getting all these people together on a single platform will be actually challenging. And there are some startups, because I will tell you about where I am coming from. I am heading the innovations hub of ICRISAT. ICRISAT started incubation facility way back in 2001. This was the first incubator that Government of India has asked ICRISAT to do. In fact, ICRISAT helped many incubators, not only in India, but also in Africa. Actually, we helped even most of the popular incubation facilities of the IITs or IIMs, or you talk anything in India, ICRISAT would have had a role in actually forging a strategic relationship with them to conceive that. We boast about it because we started it first. Then what happened is it's mostly focused on biotech, post-harvest engineering and processing and stuff like that. But from 2015 to 2016, it started slowly with tech companies coming in, people talking about applications and products and services for the farmers. So that's where the incubation facility has an arm which is called the Innovations Hub, where I work. We work with, say, all the private players on the right side of the slide. You will see right from Microsoft, X Machines, Plantex, Farm Hub, Kalkudi. On the left, and beside that, you can see Government of India, Ministry of Agriculture and Farmers Welfare. At the same time, with cutting edge service providers of real good remote sensing data, NASA, then we have big donors like Bill Melinda Gates Foundation and different universities and academia also. We also work with FAO, then African Development Bank, and this is all happening place is the Innovation Hub, because we want everybody to meet, and a new product can only be developed if everybody comes together. It's a multidisciplinary team effort. So anybody specializing in one aspect will not be helpful. Maybe you can produce a good article published in a very reputed journal, but if you have to make a product, there are other players who are equally important. Even the social engineering part, how application is made, what is the front end, back end, and how is the user experience, what is the feedback from the initial POC and the trial and the piloting or a beta version from the farmers from the field. The big problem we is it takes at least 2 to 3 years to develop. In India, majority of the season that happens is the rainfall season, the monsoon season. So everybody gets one shot, and if you're lucky and if it is an irrigated area, you get 2 shots of feedbacks. So that's how the system works here in agriculture. The risks are different. There are totally different variabilities that can come. So if you see in the bottom picture here, you'll have the tech minister, IT minister, the previous IT minister and the agriculture minister of the state of Telangana. This is our director general. They started this innovation hub in February 2017. And yeah, ever since we've been seeing a lot of leaps and bounds of sprints of hackathons and a lot of big data conventions happening at ICRISAT. And we are a part of that. But our focus has never moved away from the smallholder farmers, because our mandate is we are a public open source place for public goods. So we want to focus on our primary clientele, who are the farmers and smallholders. I mean, those who have less than 1 hectare of land. They are the majority. They are produced, 80% of the produce in the country is produced by them. Some of these companies were incubated. It's an old slide. We have to add 4 or 5 more. So these are some of the companies that are already there. Different layers and services. It is individual farmer to a group of farmers on a FPO. We call it as farmer producer organization. And there is one very good surprising ecosystem player called Kalgudi.com. So it's a very interesting startup which works with everybody. So they don't leave the traders or the middlemen or the truck drivers or the scientist or the student, everybody, right from farmers to group of farmers to everybody in the ecosystem, because they believe, and it is also true to a certain extent, if there's a problem in the ecosystem, there's a solution also within the ecosystem. So a problem can become an opportunity to somebody there in the same ecosystem, and networking them properly and making the functional digital platform is key for enhancing the abilities of the ecosystem. So that's one of the ideas on which they are working, and they have been very successful to a great extent. This is something basic. I want to tell you that this is nothing new. Whatever AI we talk, it's been there since 1990s. The deep blue computer that IBM had made, Gary Kasparov, I don't know how many of you are alive or born at that time. Sorry, because Gary Kasparov, the Russian grandmaster, played with a computer and lost. And somewhere at that time, the whole world was having a very unique front page header saying computers have taken over by the machine. Computers have taken over humans. And it was a very depressing thing because Gary Kasparov lost to the computer. And then thankfully, after 6 months, he won back. And they said, okay, humans are going to rule. The computers are not going to take away. Then we see the latest developments in the industry of automobile or limited memory and full memory cards actually for totally contactless and driverless cars coming up, and then self-awareness being an integral part of robotics. So Japanese robots that have come into vogue last few months, we also see Elon Musk coming out with one. So there is self-awareness which does exist, and there is something on the theory of mind which is in R&D. We don't have enough information to give you, but that's happening. This is really happening. If somebody is shown you in a movie, don't you think that nobody is working on those crazy ideas? People do work like that. You have no idea, in 70s and 80s there were James Bond movies in which they had the guy had a gadget like a small watch through which he was doing video telephony, and it was crazy actually. People used to see the movies for gadgets which are launched in every movie, like different things. So but in early 2000s, 2003 2 3, you see Skype has come up. It was possible to speak to people. Now Apple Watch and other devices have come actually into watches. So all these things are possible. Somebody is working. It is no more like a Hollywood drama of somebody doing it and just being in movies. So I believe, like, I'll show you some amazing examples also. For the example, this is a honeybee drone that is in the center. It's actually patented by Walmart in March 2018. Who on earth would think that a honeybee drone is required when honeybees are there? But 2007, 8, and 9, there was a huge problem with the apiary industry for the trucks which carry honeybees as business. It's a big business proposition because if you have not seen the movie on honeybee, just watch it. They are the most important creatures for doing pollination. We get most of our fruit and vegetable because of these guys out there. And when there was a viral attack and 70% of the population came down, it had a direct impact on vegetable and fruit production for the next 2-3 years. During those days, there was one small soap serial of Hollywood which showed that there were 3D printers which were printing this honeybee with antenna and camera. It was able to identify pollen, and then he was able to actually do the pollination for the female flower. So then everybody thought, okay, it was something that nobody's working on, but see how people have come up with real products that work and even patented them. So don't you think that there's a crazy idea out there and you rubbish it off? Some of these things become food for thought and ideas going into actually active walks and works to lead to products like that. But it ain't easy. Agriculture has these very, very diverse problems which other industries may not have. For example, varieties of crops. Every variety of crop has a unique DNA, its own features, its own time period of flowering and harvesting and yield potential. So whatever you make for one variety may not be actually suitable for the other variety. Same way, crops respond to their environment conditions like weather. The climate has a significant impact on it. Water, high temperatures, everything changes the way the plant responds. So even soil type, as I said in the beginning, black soil, red soil, I mean, it has a totally different response from the same seed. So this is the variability that comes in, and capturing that, if you want to automate those features or applications, is biggest challenge. Agronomy. For those of you who have never come across this word, it is nothing but the farm management practices that happen from the sowing of a seed to the harvest time. Every farmer does it in their own way. There may be recommended package of practices, but still they have their own traditional methods of doing it. And because of that, there will be high variability if you're creating a data set for automation. So ecology, agroecology, there is a high plateau region, plains, there's something near the riverbeds, then something on mountains, something above in plateaus. So these agroecologies play a big role in actually the response of how the crops respond to their environments themselves. So all these things put together, biggest challenge. Agriculture, it is not as easy as people think. Yeah, it offers great insight on looking at the challenges of variability and getting it reduced. So it's good to have those things. I will take one challenge and try to take you forward. I think the previous speaker also spoke of pest and disease. I'll tell you an example of how we started working on it. If you're not aware, agriculture advisory is given by somebody called extension workers. They work in the Department of Agriculture. I'm sorry, I'm telling you because I don't want to assume that you all of you know about agriculture and the advisory and extension system that exists in India. It's a big system. There is a lot of vulnerability of farmers. Vulnerability comes because the advisory is not timely reached out to them. There's vast knowledge, no wonder there is knowledge, but the two keys that actually help this knowledge to be given in a palatable form is an advisory which can come from human form by the extension specialist, or it can come from progressive farmers, somebody in that area who is well versed with it. So what we see is the challenge of the extension workers, like in, suppose I take example of Bihar or even Uttar Pradesh, the people, number of farmers ratio to the extension workers is as high as 12,000 farmers for every extension officer. Imagine that if you are an extension officer and you have 12,000 farmers in your area jurisdiction to whom you have to give advisory and take care of their needs during the crop cycle of 4 or 5 months, if 2 seasons, another 3 or 4 months added. So how will you cover the entire 12,000 farmers in that small window of crop cycle? It is impossible to give a proper service to everybody. Expecting that, it can be one individual can reach is also actually, it is there. You can't perform such miracles of reaching 15,000 people by one person. So the whole extension services has been under tremendous pressure. Even KVKs are there. How much pressure they will be when actually they are asked to do training. And sometimes they are experts in, say, entomology or horticulture or agronomist or a breeder, and they're expected to get 50 farmers or 100 farmers to a training program. The community-based organizations should be involved. Actually, the whole system is under stress. When they conduct program, it is always about having the numbers. And even though people provide food and transport, it is still so difficult to get people for and train the people, the numbers that they need. So the whole system, we believe, is having a stress which is expressed and not also expressed in many occasions, but it's going on. So things move on, you see. The farmers are very intelligent. They have a coping mechanism, and they're more resilient than crops because we are humans. Just a glimpse of this work that I started working with a Indo-German startup, I would say. This is automated image recognition using deep neural networks. But if you can identify that as a healthy one, on the right side, it's a tomato leaf, and the left side is having some speckles. So that's what the image processing is done, and immediately advisory is given. This is the Plantix app. You're seeing a small video on the right side. I hope it is playing for you, because what a user has to do is take a picture of a damage symptom, and within seconds, they will get the advisory not only about the detection problem, but symptoms and recommendations of how to control with organic or chemical pesticides, or the farmer is left with the options of how do you manage it. So that's what the role of this application does. It was a Berlin-based startup in 2015, but we started working with them from 2016. because I stumbled on this innovation. They had a POC that they did in Hanover University in Germany. These were PhD students of soil science. They knocked out nitrogen, phosphorus, and potassium in tomato, and they were taking images. And when they saw that this actually there is a algorithm that can actually detect and decipher these 3 or 4 deficiency symptoms, they were very happy to start this company and actually come up with Plantix application. So we in ICRISAT, we had partnerships with Government of India, the state agriculture universities in Karnataka, Andhra Pradesh, Telangana state. So what we did was take this up in a way that the crowdsourced image symptoms from the government machinery, the agriculture extension staff, agriculture officers of different districts of state of Telangana and Andhra Pradesh. They contributed heavily, and each image had to be classified, annotated. So almost 700 pest diseases and nutrient deficiencies in 35 crops, major fruit, vegetable included, cereals, fruits and vegetables, actually, everything covered, most of the major ones that we talk. It has reached over 40 million farmers, and it is in 18 languages. And it is the most popular agricultural app in the Google Play Store for most years. I have no idea what happened in the last 2 years. There are other apps, but this is one of the most used agricultural application in the world. This is a consortium of Government of Andhra Pradesh, Government of India, everybody supporting. You see, this is a public-private partnership. You individually, a person can do for say 10 or 15 or 20 or 25 pest diseases classifications with an accuracy of more than 90%, but it is impossible to do alone. It has a huge backend scientists sitting, and not only programmers, scientists and the architects of this entire application that's happening. We just launched it a year ago in Saudi Arabia in Arabic. On 10th December, we will be in Nairobi, Kenya, in Swahili language. So this will be launched there. One of the biggest things that are, I think everybody knows, the training data set is the key, and getting those training data set for the entire life cycle of a pest and a disease is the challenge. So when we did this, the initial 3-4 years, it was all about building the training data set, annotating it properly. So that is the most time consuming, and we involved at least 40 scientists from 2 agriculture universities in Andhra Pradesh and Telangana, not only to do the vetting of the content and the advisory that goes on, which is an ICR based advisory only, but also take care of the annotation work. So it was a lot of spade work done. So these training data sets we have done for more than 700 plus classifications. The accuracy is more than 93% for about 250 types. It's less than about 75%, but for more than 450, it is about 93%. We did a lot of field related testings to get to this place. Very simple application with a home screen. If you see, I told you about the product development. There are at least 150 apps that Indian Council of Agriculture and the state agriculture universities have released in the last 5 years or 6 years. But how many of them have reached farmers? There will be an inauguration time. It will come in the newspaper. But who does work after that? It's nothing like a new product is developed and launched and forget about it. In fact, when we go to the farmers' fields and when you speak to farmers, there were a lot of other requirements. Some people said, because we were in dryland areas, they said, we want weather forecast, you see, that is the most important thing. When I put a spray in the morning or apply fertilizer, if there is a rain, it gets washed away. So we need weather. So there were sprints to get back to revisit the design and incorporate weather data, give it freely to the farmers. Then there were some who said, by the time some pests and diseases come, it is too late when it is visible. It has already done damage. So whatever applications you do, you won't actually save the crops. It's too late. So can you tell us how to have good agriculture practices right from the sowings so that I can take care of the crop in a better way? So early detection is something somebody spoke, but it's not easy to do early detection. By the time the symptom comes, it actually is too late. And that's the problem in agriculture. We are trying to see how we can use remote sensing and other tools and use this as a ground truth and see if we can do early detection of stress, at least from the open source remote sensing data of Sentinel-1 and Sentinel-2, or even the SAR data of Sentinel-1. So these are the things that we are trialing and we are working towards it. But one important thing I don't want to forget here is the user interface. If you see, there are small icons. This is all coming from user interface and user experience feedbacks that we had from farmers. It appears very simple to use and browse. That's the most important thing. Otherwise, people will delete it. And especially semi-literate farmers, if there's a use, they will use it, but they want it simple. Some of the features, apart from image recognition, which is primary, there's management options also of those problems, and there is an online community. I think this is something that even for me, it was a learning curve, because when we initially had only few pest and diseases and we wanted to launch, the problem was if people had a different problem in their field, they would never come back to this app again. So how to keep them motivated and interesting was to have a social platform there where people can put a question, ask, send an image of a damaged symptom and discuss about their problem. To our amazement, more than 25,000 messages keep floating in this social media platform within Plantix app. People are there to answer it. Some people have got followers. We said, okay, the gamification of it is the best. So we see some students, some researchers, some teachers, entomologists, extension workers, extension scientists actually popping in their answers and trying to solve the problems faced by farmers. So that's very interactive, actually. That was for me the most surprising thing, because people are so ready to help others in sharing their knowledge of traditional way of, see, we could not keep any information that was not scientific. So some of the things that were coming from traditions, so they could share all that in this online community. Then crop advisory, for example, if someone gives, the farmer gives, the sowing week approximately, then the whole agronomical practices and the advisories that the farmer needs is automated based on that one small input, the time and the crop, sowing time and the crop. So that is available for almost 18 crops. This is a free application available in online in Google Play Store. And there are occasions where farmers will be empowered by knowing what it is and what they want to buy. But when they go to the retailer or the shopkeeper, they still sell them where they have more margins, not the products that were recommended, that are good. So that's why Plantix started this partner Dukan, where they have a backend support for all the traders. They have almost like in 9 states, 70,000 outlets of traders who are rurally based. Their inventory has been digitized. So the opportunity for them is to sell the right product. So any leads that come from the usage of the app by the farmer actually goes to the trader. And that's how the business model works for keeping this app free for the farmers. At the same time, the company is surviving with it. You see this picture, which clearly shows, I mean, it has reached almost all countries in the world. Then 90 million image data sets. Actually, it has crossed, this is an older slide, pardon me. It's almost 100 million now in terms of image data sets. That is the largest one in the whole world. The space it uses, the infrastructure used, imagine that. So this is no wonder India is almost three-fourth of the entire usage wise. If you see, more than 1.2 million users every month. And that's how it has become very popular. But being a research institute, we work on evaluating the performance in the field. This is some information before, at the time of pandemic, we tried to do this from 2021 to investigate how. The right side is the screenshot of how we recorded what was happening in the farmer's field, how was the app performing, what was it telling, and then we listed out with the experts, and every sample was looked deeply, and we classified whether it was doing a proper job or it was okay in giving the top diseases list if it was not able to identify, or was it completely not able to identify, or is it wrongly identifying and detecting. So even the false positives, we had to see everything, and we were reasonably happy that for a farmer in rural area without any extension service or a person, this may be something like an empowering tool. Then I come to some of the training programs, and nothing is going to reach people out there without dissemination and strong capacity building and training programs. This is a part of what we did while the pandemic was in vogue. So if you see on the right side bottom, you'll see many actually having the masks also. So this is Odisha, actually. Some of these images taken there. And we reached out to more than 15,000 farmers who had an Android phone to actually see. And they were in 3 languages, Hindi, Telugu, and Odia around India. So most of the Hindi belt we tried to capture, and the 2 Telugu states and Orissa. What do we get? This is what this whole application actually, as a researcher, I would say, because the date and time stamp is there on every image that is uploaded, and we know the exact geolocations, the lat long, that is a treasure for us because we never had this type of data, the primary data that was crowdsourced. We could not only visualize the hotspots of pest and diseases crop wise. If somebody is the district head of the agriculture department, the joint director of agriculture, or even the commissioner sitting in a state, they can actually have a data on their dashboard which can tell them what is the most popular crop in which they got more notifications. They can actually see which is the most popularly people, the farmers were looking at which pest or the disease, what was prevailing. How does this help? This will help the department people to actually put resources to address those problems. This is now no more information which is quality information, but there is exact data to show where things are happening, what is wrong at which place. So this was never there before. I'll tell you why this is important. There was a big problem with the invasion of a very invasive pest, actually. It's called as fall armyworm. I don't know whether any of you have come across that, because you're from engineering background. I believe those from agriculture backgrounds will easily tell. In 2018, around May, it was first reported in India, this fall armyworm on maize crop. Corn crop was devastated in the Americas. Then it came to Africa, and then later in 2018, mid 2018 to India. So this was actually, we were doing a live tracker, actually being able to, because we, for every image, we have this lat long and timestamp, we could automate the live tracker on a website. You may not see this live right now because we did it till 2021 and stopped it because people stopped using it. The advantage we have when we have such good quality primary data, which is spatially very specific, is that we can actually aggregate them and automate even push notifications to the user of the app, so that they will get an alert saying, hey, you're growing tomato, the wilt problem is around in your area, keep an eye on your crop's health. So those are the type of push notifications. The one on the left bottom, it's in Telugu, but that's what it says. So this is possible now, alerting people that there is a severe problem in this crop in your surrounding areas. So this was not there before. All this is happening because of the advent of tools and technology and the Google Analytics that's enabling us to do all this works. Yes, I'll give you more deep dive into what happened with the fall armyworm. We had taken, or we culled out data for 2 years, and one of the PhD students in the University of Strathclyde sat on this. This was from her work. We did the odds actually of fall armyworm against a healthy, and we found the invasion started in South India, the violet curve, and then it moved towards the north. But we were also puzzled when we saw there was some data coming up in the early January and February. So then we went back and we got back the images with the time and date stamp. We were stunned. In January 2018, 21st and 23rd, we had these reports from India. See, that was a fall armyworm, and people were sending images. Plantix was giving back answer because there were trained data sets for Plantix fall armyworm from North Africa, because we had a couple of people in North Africa who were sending us images, and a fall armyworm data set was already there. But why we missed it, that was a serious concern for us, because we never knew that because the app was giving answer to the user, but we never knew that there was no repository of the risk register of pests and diseases that are not there in India, and that can be considered as invasive. So we missed out the fleeting glory of actually identifying it. This is also published, and it will come out in the PhD also. It just completed recently, so it will be online soon. This is one of the conferences where it was presented. So technology does most things, but it needs a human intervention, no doubt about it. Otherwise, we will miss, and there will be only learnings like that. One of the biggest reason I believe totally is the public-private partnerships. You can have the best idea, best things in your mind, but if the government supports, then the private players, the startups get a boost. Otherwise, it will be difficult in an environment like India, because nobody pays for advisory, nobody pays for ideas. There are more ideas in the graveyards today simply because they have not been funded, they have not been mentored. I can say there was no support. There was also daydreaming, I can say, which happens in most startups. See, having the best idea is not the issue. How do you de-risk to make a product? How do you have a business model to sustain it? Because the direct clients may not give you money. Thanks to Google, Facebook, or WhatsApp, they still are making their own money because there is a model that works. So people have to be innovative in this sector to make money. And if you do not make money, you will not survive. The best of the best startups which got a lot of money and grants have vanished in 2-3 years' time. Plantix was launched on the left side by I wrote here ex-chief minister, but he has again become the chief minister, Chandrababu Naidu. Then Prime Minister gave me the chance to demonstrate to him. This was way back in 2018, on March 17th, at the Pusa campus, in IRI campus actually, in the Kisan Unnati Mela. So all these things could happen because we were able to use AI and demonstrate it, not only in experimental places or putting an article publication. That's why you find very few articles. We have some book chapters and couple of conference papers which we did. There are also 2 other articles which others also did, but our focus was on how can we take this product into the field, to the farmers' hands. The journey of this company, now it is based in Indore. It's a Indian startup, Plantix India. It was a Berlin one. So that's what has happened. If you see the journey, it started in 2015, and 2016 they came to India, and the partnership started with the CRISAT, and we had partnered with the universities, state agriculture universities, and ICR institutions. And slowly we went for a launch in one language, in Telugu. Then it went on to become rapidly, scaling up in other languages, and huge number of users started using it, reusing it, not just once download. The actual indicator of success is reusability. So in those areas, Plantix has done very well, and they now recently, last year actually, they have joined forces with Helmag. Helmag is like Corteva and Bayer. It's a German giant, a 10 billion euros company that has taken significant share of Plantix. So that is the opportunity for good startups. And they are trying to make themselves break even in India by selling the goods which are proper. Some people talk about non-judicious use of pesticides. I think that's where digital influence can actually, digital products like this can actually render some peace to the environment and to the people's lives, because there is non-judicious application of many of the agrochemicals presently in India. So the ecosystem is being captured. It started like okay, I will give service to the farmer, but how do you retain that service for a period of time? It has to be through a business model. That's where, if you see the right side, the other things came up later in 2022, more in 2024. So this is something that keeps the company alive. If they just sit with a product, who is going to care for it? So that's how the sprints are important. And also, companies need to work based on some business models which are innovative. Otherwise, looking for grants from government and taking loans will not be a long-term solution. There has to be something else, a way of making money, make it work in the same ecosystem. Here is another idea of ours. We won the CGR's Big Data Platform Inspire Challenge Award. It's $100,000 that we won. We started working with PureScan AI company because in my PhD I did non-destructive techniques. So aflatoxins are very serious problem. We see them in groundnut, many of the nuts, maize, chilies. So anything that contacts ground, there is a problem of actually having this contamination in the food. It's a food food safety issue, major one that hinders exports. So farmers, they can't sell more to European Union or North American markets because they are very critical of less than 4 ppb, parts per billion of this mycotoxin. It's produced by fungi. So it's got a unique thing like a fluorescence under UV radiation. So first 30 days. So we started using this because ELISA test, which is done in a laboratory, takes 3 days for that sample to come, and nobody waits for that time for this analysis. So that's where the farmers lose price, because traders will buy it at a cheaper time, cheaper way, and because this is not there in grading, nobody talks about it. Poor farmer doesn't get the money that that if it is of good quality, they deserve a higher price. The incentive of looking at quality is higher price that they can get, because it can be exported, export quality. So we wanted to target with $50, if we can make this device and make it available in the field or in the market yard, or a group of farmers can buy in that place, like a farmer producer organization, this will solve and disrupt the way trading is happening in some of these commodities. So this is some work that we did with the private startup. Not everything is good with the private startups also. The startup is non-existing after 1.5 years. They had internal problems and it got dissolved. We are nowhere, actually. We are a research team. We would like to help people who would come forward to make those devices. So this is still an imbroglio, but we will be soon getting someone's help very soon. So we've been discussing this with other organizations and other startups. So things like that can go vary. So you must have heard about drones being used everywhere for spraying agrochemicals. That's not the best thing to do. Okay, it has reduced the chemical content significantly, but still better is if we can know the exact pocket where the disease is and only spray there. See, that is the use of a drone. With a multispectral drone, it is possible to actually decipher. This is an example of a wheat rust. It's a chickpea rust, sorry, that we did in our own campus, ICRISAT in Hyderabad. So those faint red rust affected areas on the right, this is the orthomosaic on the left, but this is how we could come up with QGIS software, very simple ones. We try to look at this 10 band spectral. If you can see on the right side near infrared region, that is a place we got the exact delinked, the area of soil and the rust along with the healthy crop. So the soil was the same. So we had to go back and see how we could decipher between the soil and the rust at another place. So this is quite possible. So we had to do at 2 places. First, we had to get soil out. If you see 685 nanometers, and then we had to do a further filtering at 850, so that we are very sure that this is the rust affected area. So this is something of the future. we don't have this happening in the field because it takes 3 to 4 hours to process this data. Maybe with the advent of more speed and hardware quality improvement, it is possible to identify and again spray at the instantaneously at the spawn at the place. So it's not just the first scout will be for identifying the hotspot. The second scout may be for after 3 to 4 hours to actually go there and spray. So this is what we see as the near possibility in the coming months and years. And I will quickly go to another place where we used AI models, very simple regression models, of course, not even ANN or random forest, but there is something called crop cutting. India does 6.5 lakhs to 7 lakh crop cuttings in the Kharif season, and in Rabi season, almost 4 lakh crop cuttings. What a crop cutting is, the field officers, the agriculture officers or the extension officers, every year they will have a target during the season to estimate the yields so that the crop area and the corresponding yield from that crop is estimated and put into the Bureau of Economic Statistics. This is the stats that is done normally. So when they do it, the harvest window will be 2 to 3 weeks in a region. So they have to perform, say, 150 to 200 crop cuttings. It is impossible to do that. Anyone with 3 or 4 laborers in a 5 by 5 square meters area, if you have to do this crop cutting as a sample for every hectare, it will be so laborious and it is impossible to cover everything. So what they do is they cook in data, fill the data Excel sheets and send. Off late, government has given them apps. They are still able to get away because they can just take pictures and still write some entries into the app. So this problem is yet to be solved. So we were given this challenge grant from the BMGF. So University of Twente from Netherlands, IFPRI is International Food Policy Research Institute based in Washington. So we did this POC. It was very simple. We wanted to do for a couple of crops where the panicles, the fruiting body is at the top. We did a 3D point cloud using 10 to 15 images, or even we were able to do with a 9 to 10 second video. We could cut the slices. So the point cloud we put it, and with the Archimedes principle, the physiologist was able to tell us the weight for that point cloud. So this is how we then came to the point of giving a prediction value which is very near to the actuals. So this is the one of the ways of doing it. You must have seen the LiDAR used by the architects or the civil engineering people. So we exactly did the same thing using a smartphone. Our validation has to be done using a LiDAR. So we are still waiting to take this forward through the support of the crop insurance industry. So many of the insurers, we have done this and presented to them, and government is also willing to take a look at how we can do this, because in a 1 minute time, you can do a sample. So even if you do 10 in a field with different sizes of the panicles or the fruiting body, you can average it out and say, give a very reasonable harvest index. So that's the advantage of 3D point cloud, 2D to 3D transformation that we were able to do. So this is something that we did using remote sensing. The problem statement was, everybody talks about predicting yields, but usually it comes at the time of harvest or after everything is done, because we will have those validity. So this problem that came was that there's a Reddy's Foundation which was working in Samastipur in Bihar, in one of the districts, in 1,250 villages. They had almost 45 staff working there. It's a development project. The question was, during the crop cycle, while the crop is there on the field, can we predict the yield? That was a question. So we had the ground truth at the end, the harvest data, so that we could see the actual compared with our predicted values. So we used Sentinel-1 and 2, and because of the SAR data, the radar data that was available in Sentinel-1, we could make a little bit of progress with vertical and horizontal polarization data. So the ratio of it also worked well. We could decipher, because these people were giving nutrients like the soil health card and the nutrition to be maintained in the crops. and some places they gave varieties. And this was compared against the control plots, which were actually the farmers' practice. So we could see the difference between both. Because usually people in the developing sector or even researchers are tend to put a 20 to 30% higher for a variety, simply because they believe that it is true. So that is the error that happens. And they wanted a remote sensing tool to be used here. So we were very successful to actually break it down and see that random forest was wonderful in actually doing the prediction. It's a very high quality of prediction if you say random forest for us, even for the validation data and also for the calibrate training data sets, we could get amazing number actually. So when RSME also was very low. So this was really important for us because this POC we did, and we actually have a Google Earth engine that can actually do it for entire state of Bihar. It can be used again for other places within India. So this is something that as recently as last year. So we are trying to do and see how we can take this forward further. Because remote sensing tools can be used, not only satellite drone, we can actually do a much better work in predictions. There's a very big invasive weed called water hyacinth. This you see in the lakes. It's very popular. Any abandoned lake or even in the cities, we see in many lakes this problem. So what we try to do is put some sensors in the waters to see if quality has been affecting this weed. It's a very bad weed which is not managed properly. People spend crores of rupees every municipality to clean them, but it pops up again because the seed is so small, it goes and settles at the bottom of the lakes, and it is viable for almost 25 years. So there is no end to it. So we thought maybe if we can harvest it and we know the biomass and if we can predict, some entrepreneur can make use of it. So we started working with some entrepreneurs in Kerala who make bags. Some of them make paper. This is happening. So we also used the spectral signatures that we got from Red Edge Band and NIR to actually decipher that because the quality of data using drones is much better. But at the same time, we could see that writing a transverse algorithm with the freely available Sentinel will help us in a big way. So this work we also did in this year. We actually have a publication from Lake Victoria in Africa, which has got the same problem. So we can relate these things and use it at different places. The quality of the algorithms are so good that this was actually published very recently in one of the good journals, 2024, on Lake Victoria. There was a development project in ICRISAT working in Odisha state, where we were doing soil health monitoring for the entire state. So there were about 1,000 plus samples for each district. So what we did was, because that was used as a ground data, we tried to see if there was a satellite data that can actually correlate first with any of those variables like soil, pH, nitrogen, phosphorus, or potassium, or even carbon. And we could see that the relationship with pH was so high. So when we knew that, we were then able to publish. This is big data analytics. We had to see the correlations of every variable against the satellite time of we did somewhere in April, May, those data sets in that year. So we had to go back and retrieve those satellite data and actually see and compare. And we were happy to see that the pH was really powerful. With remote sensing, we can actually predict pH. And because we are still doing a project in Odisha, we want to collect data again and see in these districts in April, May. We're going to see whether whether our predictions are true. So that's what is going to happen. If these are tools and if our predictions are good, then we should be able to test it again in the future and see whether it is actually being able to, say what we have predicted. I mean, that's reasonable for all researchers to do. And the buzzword of late is the climate change, climate smart technologies. I think something that people with who have a confusion or who try to relate climate crisis of every place in the same way is very wrong in agriculture, because what is important at one place. Maybe 15 kilometers away, it could be totally, the microclimate can actually challenge what has been predicted or what is happening there. We have come up with an intelligent systems, agriculture systems advisory tool. What this tool does is, we did it in Maharashtra, Andhra Pradesh state, and now in Odisha we are doing. So we did this in Maharashtra maybe in 21, 22, but right now we are doing it in Odisha only. It started with Andhra Pradesh on groundnut crop. Then in Maharashtra, we did it on pigeon pea. What it does is, like, we take the historical data to tell the farmer whether the sowing window is there for them to go ahead with sowing. And during the season, weekly advisory is also given to them on what they have to do based on the weather predictions that are happening. So the historical data of 20, 30 years, it is used for actually predicting the sowing window so that they can go ahead. So this is how the decision trees come into picture. The agronomy part is already done. Everybody, any meteorology and agronomy expert would have done this already. We are trying to put it in a palatable form and the science-backed tool that can help farmer during the season. So these are some of the things, the decision trees that need to be developed and automated. So we are trying to automate this, but mind you, climate, getting the granular data, that is the biggest problem. They come not for village wise, we have a block wise. Block may have some 60 villages to 100 villages. I mean, in some areas, actually, it is so big. Some places, the blocks have 20 villages. So that's the sizes of the blocks where we are getting weather data, which is very critical for actually doing any prediction, good quality predictions and advisories in agriculture. I come to one of my last slides. This is the in thing. This is the which is going on. We have more than 200 companies that are working on MRV platforms, monitoring, review, and verification, reporting and verification platforms, which is popularly called as carbon credits, giving back to the farmer if they have changed their way of practicing agriculture, like wetland paddy to a dry land paddy, or having less use of water, or even pesticides and fertilizers like nitrogenous fertilizers, reduced use of it. See, all those on the left are contributing to greenhouse gases, the carbon sequestration, and getting more regenerative practices and improving the efficiency, nutrition efficiency, reducing the footprint of carbon and sequestering more or retaining the carbon back in the soils and the environment through agroforestry or ecosystem services can be very useful. So that's how people are now, because there is a green credit policy already in India. There is a panel for carbon credits to see that the farmers benefit, because everybody sees that if you can trade some of these credits in Europe and North America, the companies can make money easily because the farmer is gullible in India. So we want to be those intermediaries who can broker honestly for government and between the private and the farmers. So that's coming up. That's big way. So this is the area where you see more innovations coming up. And we try to put them into 3 classes, but that is not a fixed one. This is because of the work we did recently for digital agriculture strategy for India. So there are last mile connectivity issues and themes which people work on. Some are yield enhancements, these are productivity related mostly, and investment in policy, as I said, MRV platforms and blockchain fintech products for the farmers. So the digital ag space is big. And one important thing research area wise is One Health. See, whatever is happening in crop health is actually influencing animal health and also human health, because everything is connected and interrelated. So right from soil health to the plant health to livestock and human is all in One Health mode. So all these disciplines which were supposed to be done independent of each other, now people are seeing the usage of coming together to address the problem, because they are all interrelated. So no more working in silos of specializations. So this is how research is done in most developed countries. And I think India is not far off, where we dismantle this specializations, because they actually hinder teamwork and multidisciplinary teams, which actually leads to new products. So thank you for this opportunity. These are some of our funders and people with whom we work, and a team that is there in the Innovation Sub. Yeah, thanks for listening and feel free to ask me questions.
Yeah, thank you, sir. I have given rights to the unmute the participants. I request the participant, if you have any questions, they can unmute themselves and ask the questions.
Hello, sir.
Yeah, ma'am.
Sir, I want to know that in case of Plantix, it is such a successful app and you have used 700 classes. So can you just put some light on the architecture which has helped you to achieve such a good performance of an application? Was it a deep learning combined with segmentation or something with respect to research perspective?
No, the first thing was segmentations, of course, but annotation. Individual image annotation is key. The experts actually sat with, I'm talking about 500,000 images here. So you can imagine the amount of work they did. This is critical. And of course, the success also is because of the good brains we had from actually Oxford and Cambridge, who are part of Plantix at the back end. So the architecture was revisited so many times, I'm telling you. It's not easy to put that. The sprints they made, 12 to 13 sprints in the initial years on an average. It was deep learning only, but you need to actually tweak the algorithm. It's like you have to retrain it continuously. As in long, you keep adding more. The challenge of actually the performance accuracy comes down so dramatically fast. So I give all the credit to the backend team. Actually, it's a huge team. I'm talking here about more than 35 people, data scientists in Berlin.
Thank you, sir.
And in fact, the good part is the API is free for Government of India also. So these guys don't make money from the government or the people. They only charge the private players. Yeah.
Yeah, anyone else want to ask the question? Okay, sir, just for as we have seen, the AICTE has developed so many incubations at different locations. I just want to know, we have a very different participants from all over India from the academics. So how students can collaborate with the AICTE?
Ikrisan, we have a lot of students coming from engineering. I get interns from all over the world actually, regularly from the NITs and the IITs and those engineering colleges surrounding Hyderabad. They do come for 3-month period. We give a training data set for one crop for 10 to 15 classified disease pests. And we try to tell them to look at different models, come out with which model works, why it doesn't work, what did you do which is different. So in 3 months, they'll do this live project because we have this training data sets apart from Plantix app. We have done that for our own in-house app development. We captured a lot of training data sets and prepared for more than 100 pests and diseases. So we can do that. So I give that opportunity to students from most of the engineering colleges. They do come most of the second, third years also. Even second years, we take them after 2 years. Third year, yes, the best time to do something on deep learning. All these 5 to 10 is like if there's a good student, we have gone up to 20. They've done very good. I have their reports and wonderfully done. So all they need to be having is that exposure. So that's what we do at ICRISAT. So we have a co-working space. They can come sit. We attach them to one of the data scientists. They can ask them questions, keep them fully occupied with the works of, even sometimes we withhold the annotations done by others and ask student to learn how to do it because they have to do from scratch. They can't just use a model that is open source and say this is done. So we want them to learn and do the whole process properly. So that's where process engineering is most important, even in AI/ML.
Okay. Sir, you have shown various different applications or the digital application that can be used for the agriculture.
Yeah, I've shown some of the applications that we did for in digital agriculture. So what's your question, sir?
Yeah, so the question is, as a academician, uh, many times the students ask where to start with the different problem statements.
If you really want to do a project, review of literature is the starting point, as you know. If we don't read the proper latest review papers, at least on a topic, in agriculture problem statements, you will get any of the journals. I say the generalized one is take economics one, because they'll talk about money issues, but they also point out the real problems. But at the same time, don't be fixated on economics team. The real things are agronomy, or what the farmers do in the fields. So there are many extension journals that also point out the problem areas. So that's the way to start a problem area to be picked up. And you can be assured very few people have done the solutions properly in this area. It's still evolving. There are mushrooming startups who are working. There are students who are interested, but very few are working towards the goals of servicing the farmers with an application that works in the field and remains in the field. It's too early, but at the same time, I can say if they have survived 4 or 5 years, they'll stay longer. The first 4 years is the biggest problem, because uh, that's the time you have to have a business model. Otherwise, you will not be long with investors pouring money. For students, please, I mean, get into agriculture sector to get the experience. Even if you're not in agriculture sector later, this experience will be very useful for them. Other sectors will be much easier for them to work on AI/ML and robotics.
Yeah. Sir, we have some questions in the chat box. Can you please suggest a few research problems?
Shall I open the chat? Okay. Can you please suggest a few research problems? Okay. One research problem very clearly is autonomous vehicle. The labor problem is heavy. If you can look at a autonomous vehicle design, it will work in India because there are orchards. If your focus is on horticulture orchards like fruit trees, it works very well because these are all labor intensive, and areas of picking up or harvesting. There are big harvesters for the field crops, but for the fruit and vegetable crops, it is still the human labor. These things are already done. Say in Netherlands you have, or California, you have these companies that are doing. But here, we don't have any indigenous, technology companies that have come up with robotics for harvesting vegetables, say even tomato, for example. So that is the area that is very wide open. And second area is if there are post-harvest problems, as I said, quality, and you can use AI for determining quality. Somehow Amazon has not done a good work. Even big basket is facing problem. They only procure from very nearby places. So students actually, or researchers can actually focus on how to solve this problem, which is really not helping farmers. If the more we delay this, the money they make will not be increasing much, because ultimately they have to make money. So production way, people are more focusing on done because, but outputs, I think that's where if they can crack it, it will disrupt the way trading is done. So that's one very important area. So, Robofo platform. Oh, there are many platforms. Can you just don't limit yourself there? Goes and do a proper search. There are many online free platforms for annotations. Don't limit yourself with that one. Feedback link. I know Dr. Shilpa Joshi asked. I don't know. Srijanath, I'm Srikanth, very much thankful. Okay, I don't see any more questions. Okay, feedback forms. Okay, so can we deploy multi-agents framework for decision making? There is a risk. Some things which work in a sector may not be replicable to the other. You can't translate it. So what is working in the decision making? The decision trees should be very, very clear. Unless the person who is designing the decision tree has the clarity, you can't automate that. Please, again, there will be a problem with that very decision taken because your ranges are wrong. What ranges you gave? See, I think ultimately you have to fall into a window of numbers for which the decision is made. And those should be very clearly science backed. They're not theoretical because we're talking about agriculture and farmers. So better be very careful when you look at those frameworks. So what else?
Yeah.
Yeah.
Yes, sir. Thank you, sir. So we have, so you have covered almost very digital technologies that are applied in agriculture. I hope the research areas that you have pointed out during your presentation, as well as in the question and answer session, may be going to help the participants to look up some of the research. As you rightly pointed out that many ideas are in the backyards due to we do not have not having a good business model. So I wish whatever the research problems are there, the participants will take up that ideas, their research problems, and will develop different type of business models so that that idea can survive.
Yeah. Thank you.
So
Great.
thank you, sir, for accepting our invitation and delivering this wonderful talk.
Yeah. I mean, it's a pleasure actually. It's mine too. And hope your students get the benefit. And if you want to send any student who can afford to be in Hyderabad for 3 months, send me them. Yeah.
Yes.
All we need is 2 references, teachers referring them. If they are from Hyderabad or I mean, if they can stay, they can visit iHub. This is a very unique place, I can assuredly tell you. When they put it in their resume that they did an internship in ICRISAT, some of them have got good offers in their master's programs in the US. Some of them do very good work. Yeah. Cheers.
Yeah,
All the best.
definitely, sir. Definitely, sir.
Thank you very much, sir, for
Yeah.
accepting our invitation and enlightening us in a very cutting edge technology. Thank you. Thank you very much.
Welcome, sir. Bye. Good night.
Good night.
Bye. Bye. Bye, sir. Good night, sir. Good night.
Thank you all the participants for joining both the sessions. I have shared the feedback link in the chat box itself. Please take a few minutes and submit the feedback. Then you can leave the meeting. I request all the participants, please join all the sessions so that because we have there is a certification criteria from the AICTE that you should have at least 80% attendance in all the sessions and should get the 70% marks in your test, which will be covered at the end of this faculty development program. I also request all the participants to join with the name by which you have registered with the AICTE ATAL portal. Those who have submitted the feedback form, they can leave the